I'd just like to welcome everyone to tonight's session of Careers in Technology. We have Dr. Baek-Young Choi. She's internationally known. She's an internationally leading scholar in the Internet of Things, 5G and beyond, cloud computing, and cybersecurity. Dr. Choi's innovative research has led to numerous Best Paper, Best Poster, and Best Video awards, as well as recognition as conference keynote speaker, distinguished lecturer, and associate editor-in-chief of the flagship magazine of the IEEE Society. She has served in many international leadership roles in her technical society, including Chair of IEEE Women in Communications Engineering. You might have heard the acronym WICE, and that's how I first came to know Baek-Young. That's a fabulous organization. It does an awful lot. And we had a couple of projects we worked on together with WICE. She's chair of sister societies and a technical oversight committee of flagship conferences in IEEE, general chair, and technical program committee chair for multiple international conferences and workshops. This is the rough outline of her talk as of a few hours ago, but I think it's been updated since then. And I just want to remind you folks that we have some other talks coming up. As you might notice, Dr. Koutsoukas is actually with us tonight. And in between, we will have Mr. Eamon Wall, who's a patent attorney, Dr. Rui Lee from Montclair State. We have Dr. Alvin Chin from Chicago. Obviously, Dr. Peter Koutsoukas, who's with us tonight, is also from Region 1, and he's from the Connecticut section. And Elizabeth Alvis will be with us on March 4th. That's the regular series. And a special event we have tomorrow night, we'll have our very own Dr. Paula Mueller, who's an entrepreneur, who has a company that focuses on helping people age with dignity. So we're looking forward to all of these events, and I'm going to turn the talk over to Dr. Baek-Young Choi.
Can you see the full screen of my slide?
Yes.
Okay, so you see the slides, right?
It looks great. It looks perfect.
Okay, great. Thank you so much, Dr. August, Kate. It's my honor, pleasure to be here. I didn't have a chance to see how this talk, this kind of talk will be like. So this is the title that I was given, and Kate told me this is gonna be very casual in format, and just talk about me a little bit in the career background and some of my projects, and have a lively discussion. So this is the updated outline that I have prepared. So please do feel free to they have a comment, ask questions as I go. So I will start with my personal background. So as Kit has mentioned, I'm with University of Missouri, Kansas City. I've joined in 2005. This is my 20th year. Cannot believe that it has been 20 years. I did my PhD from University of Minnesota, a couple of years of industry research and the visiting professor experience. I decided to join academia. So I had some industry experience, and then once I started a little bit of the taste of the academic environment, I just loved it. So the next year I actively went for the academic path. These are my research interests, and I teach courses like cloud computing, network architecture, blockchain technologies, and so on. So I did industrial research at the Sprint Advanced Technology Lab in California. And as said before joining University of Missouri, Kansas City, I had a visiting professorship, and I recall the first day of this semester. I was away from university just a couple of years, and then went back to academic environment. I saw a group of students walking toward the building, and I just felt amazing energy and realized that that's the environment that I wanted to be in. I also had a number of summer faculty, the visiting research experiences in different institutions like NASA, Air Force Research Lab, and the Korea Telecom Advanced Technology Lab. As my name, the probably from my name, you can tell I'm originally from South Korea. I visited KT Korea Telecom for one summer. I also do a number of services in the society, IEEE Communication Society level, of course, other internal services as well. So a little more about me. I am definitely an introvert. Okay, I couldn't imagine that I will be in a job that I have to speak a lot, right? I loved science and math, and when PC was first being introduced, I decided to major in computer science. And my sister told me, "It's good that you are doing, in computer science, that you are working with computers rather than people." That's what my sister told me. Um, Now, I do enjoy talking to people. I'm a little, better than before, but in still many standards, I think I'm introvert. Okay, so it
So
is
I think
great.
this is like when you have a role to play, like I classify myself as an extreme introvert, and I know it might be shocking to people who know me, but I was forced onto the stage as a child. I had to take, I was the person who was given the lead in the play, so I would develop my voice and the piano and being on the stage, all of this stuff like designed to make you go there and do the thing you most are afraid to do, right? But there's a thing that we have in our hands, this technology thing, the story of the technology, the story of helping people find their own voice, right? It's a
Mhm.
great thing when you're now in a classroom, do you feel like you are empowering others to find their voice? Is that something that helps you with the introvert part?
Um, Definitely, the classroom students, except a few, most of the times, the people in technology, computer science, they are introvert. I didn't really explicitly think that I am empowering them necessarily, but I can definitely emphasize I have an empathy with them. So I hope that they would be more comfortable in that sense, it's empowering. Yeah. Yeah, right. So I now think that the people do recognize uh, the power of introvert, or being okay being it is okay to be introvert. Still introverts, there are great introvert leaders, teachers. So you don't have to become an extrovert. Still, can do your work in a very different way, still, making impact. Right? I hope. So
Thank you. And
yeah.
there you have these beautiful girls. How cool is that?
Right. Yeah, I am a mother of two daughters. And today I thought that maybe I'm going to talk about a few projects, the particularly relating to Internet of Things, but the out of the IoT project that I have worked on, maybe the works that were inspired by my daughters. Okay, so um, the in technology, one of the great thing is that it's not completely, the out of our life. We can relate a lot of our work with the real applications that can impact people, and these are some of the examples. I think it might be easy to explain. Hopefully, uh, the it makes sense, easy sense for you, and how technology can help people. So just, the acknowledgement for students, collaborators, colleagues and my daughters, right, and funding agencies. So Internet of Things. There are a lot of things, thing one, thing two, um, and the internet part makes things smart. We talk about a lot of smart things, smart cities, smart TV, smart watch, smart health, smart home, smart car, smart space, smart industry, smart grid. So many smart things. The smart part comes from the internet connectivity. In the old times, or the traditional sense of being smart, it used to be about the thinking well, doing computation fast, and the you know remembering things well. But now we have computers who can compute in high capacity very fast, and we have a huge infinite amount of storage. So the meaning of smart, it basically means that having the internet connectivity, and if someone has the internet connectivity, or if things has an internet connectivity, then we can find things easily, quickly, and delegate things quickly. So the one, rather than the person on the left who just, they reads documents sequentially in a traditional manner, the girl on the right who has an internet connectivity will be able to find things really fast, and, get the solutions uh, quickly, right? So that's the intuitive sense of the smart. And now we say intelligent things, and that includes the use of AI. And we have a lot of technologies, applications that has an internet connectivity, and AI make things intelligent. So the IoT is the word that I have used in the US. The CPS is another related word. The In fact, if you go to the Europe, they don't use the word CPS. I find the only IoT. We want in the US, we want to distinguish them a little bit in terms of the scale type of system that are connected to the internet. But I would think that the technology is being used for IoT or CPS are similar. So I'm going to use them interchangeably. So it is an intersection between physical and cyber, the system. And once it is tapped with the internet, with the cloud, it has a powerful, the potential for analytics, storage, and even users, people too. And IoT isn't just occur, one day, ta-da, but there has been precursor technologies like embedded system, wireless sensor networks. Um, Cloud can be far away, having long RTT round trip time. So for some real-time applications that are delay sensitive, the computation is better to be near where things are happening. So we have now cloud, not only cloud, but also the fog or edge, something smaller scale near the physical system. So this is the typical technology, the architecture we can think of. So the IoT word has been there for a longer time, but only in 2016 in Davos World Economic Forum, people recognize it. Now we are at a new the new level of it's the new time of the society where the boundary between physical and cyber system, even biological system, it gets blurred. And the major technology they have identified in 2016 is a CPS, IoT. Now we talk about the AI more, but it fundamentally being connected to the internet was the main thing. So I thought I'm gonna introduce some of my IoT projects. I'll try to be brief and intuitive, but feel free to stop me anytime. So I'm gonna talk about the project called Wi-Fi Honk, Wi-Fi Amber, Auth, and Optlock. So these are IoT projects based on smartphones, and they have a real practical use. So fundamentally, we need to have a connectivity. Wi-Fi honk enables the connected road, basically the pedestrian and the mobile cars. So the motivation is the my older daughter, who was a teenager then, was distracted to a smartphone all the time, listening to music, doing different things as she walk or whatever they whenever she's awake. And I realized that when she has a headset, she won't be able to listen to other things, especially like honks, and that creates the danger on the road, right? So the automakers, of course, found out that's an important issue, need to do something about it, and our idea was that people doesn't hear the honks alerts coming from the car because they are distracted to phones. Why not giving the alerts to the phone? So that's our idea, and we named it as a Wi-Fi honk. So we use Wi-Fi in a novel way to give an alert to users. They can be pedestrian, vulnerable road user, or driver. So existing technology called DSRC is the 802.11p was designed for vehicular communication. However, even after 10 years, it's not so the work we have done was in 2014, 2013. Even now it's not deployed. It's the wide deployment and adoption can take a while. And also when it's done, they're pretty much done, still retrofitting for older models of cars will not be possible. And the other method, cellular, it's not for instant messaging. It has a long association time. Existing Wi-Fi, the it has the association time, and it doesn't allow for high mobility communication, because if you look at the Wi-Fi messages, it has authentication association, which can take a few seconds, and during those time, incidents may have happened already. So Wi-Fi as is couldn't be used for high mobility communication. Our idea is that Wi-Fi devices sends beacon message by default 10 times a second. With this short control information. And our idea is that embed important information on this special field of Wi-Fi. So we call it Wi-Fi beacon stuffing. And we find that this can enable up to 75 miles per hour, high mobility communication, instant communication. So that's a pretty high level of description of Wi-Fi honk. It can be used for the special controlled environment where pedestrian and the cars are coexisting, like a cargo distribution center, or even in airports where things are noisy. If you look at these people, they are plugging their ears because it's too noisy, and they won't be able to hear any honks. So in such cases, the collision possibilities is still high, and Wi-Fi honk can be useful. I was working at the Air Force Research Lab at the time, and the team, they where I was in was called offense team. How can we use this technology for offensive manner? And this could be like in covert communication, like a spy movie. When they come across, they quickly, without saying any word, but still some messages can get across. So that was about Wi-Fi honk, and then Wi-Fi Amber. So one of my daughters, when she was young, we took her to Disney World, and we lost her, and that lasted maybe a minute or so, but it felt like an eternity as a mom. So the children can go missing. How can I keep her around me all the time? That it was a thought, and that gave me an inspiration for the idea called Wi-Fi Amber. So we know Amber Alert. I saw recently a movie, Amber Alert, in an airplane. So Amber Alert has started in late 90s after the missing child of Amber, the Hagerman. So the that when child goes missing, there will be an alert, on the street on our phone, and when people they see this message, we call to the National Center for Missing and Exploited Children, and that this Amber Alert has saved a lot of the children. Still, look at the number of children who went missing, who are reported missing, and successful recovery cases. There is a big gap. This in the data, I got it initially, 2015, 16, when we have done this work and giving a talk. Recently, I double checked, and the number has gone up, of course, but it's not much. So that still now we can do, I think, better than that. So the idea is that let's use the community. There is an African proverb saying that it takes a village to raise a child. It takes a village to protect a whole child. And that's the main idea of Amber Alert. And it's particularly critical to find the missing child within, first 3 hours. If we decompose the process of Amber Alert, there are two parts. One part is spreading the news. This child is missing. And then the second part is searching together. The first part, spreading the news, has been modernized in many ways. Road signs, phone messages, even Google, Facebook, movies. However, we find that searching together, the second part, it is still primitive because people have to remember that message and look for the missing child's any, description matching the person or cars. And then we give a call. Then National Center for Missing and Exploited Children, they have to process this one. A lot of these calls may be not deserving for further exploration. It takes a lot of time and it takes a lot of cost. Also, for parents, it's not easy to do that because once you first of all, report it cannot be easily done because they don't want to desensitize the community with the wrong or too many alerts. So not an easy step. Our idea is that let's use Wi-Fi, which is available on pretty much everybody with the smartphone. Then the next issue is that where will people really use it because they may not be willing to participate in this searchy process because it involves the extra battery and additional time effort. So our research work includes the addressing those concerns. So here's the architecture. There will be a Wi-Fi tag that emits signal passively. The actively with a certain signal, and then the parents or caregivers will receive this signal, and if they receive this signal, it becomes geofencing. But if a child goes missing, then parents caregiver can report through a cloud server, then location-based alert search messages they will go out to the volunteers crowd, and they can track these messages and report to the cloud. Everything can be done automatically without human intervention. So the first of all, architecture design, and then we have identified a number of technical issues that includes the effectiveness of Wi-Fi compared to Bluetooth, and the use of Wi-Fi can be actually found it's turned out to be a lot more effective in terms of search because of wider transmission range compared to Bluetooth. However, it is the infamous in terms of battery, the energy usage. So we come up with a scheme that can be more energy efficient despite of use of Wi-Fi. And then there are a number of adversary models, security issues, and we have a scheme addresses all those. So this is a sum of them. The way to improve the protocol to save energy, we reduce the number of responses that are unnecessary, and these are the adversary models that we have considered. At that time, we have built the system with a prototype using Raspberry Pi, and this is the different menus. We considered a number of different usage cases. This is not cellular based. Existing solutions are either Bluetooth or cellular based. Bluetooth not effective enough. Cellular-based one is expensive, and someone who has a disability may not be able to use it, give a call. So this can be really used for things or people who has a difficulty of making a call, emergency call, and so on. And it will be low cost. At that time when we worked on, there were 2 prisoners escaped in upstate New York, and we thought that this is a great case where this technology can be used. Okay, so that was about Wi-Fi Amber after Wi-Fi honk. Next one is rather than Wi-Fi, let's try to use different direct communication method. So if you look at the RF radio frequency spectrum of Wi-Fi or Bluetooth, Z-Wave, Zigbee, that's all radio frequency range. There are so many protocols running, so many devices running. Maybe there are so-called RF smog, too many signals interfering with each other. So rather than RF range, how about using a completely different range of electromagnetic signal, like infrared or visible light? So we have done different applications. The first one, let me show something about the VLC, visible light communication. It has a high directionality. So visible light has actually received more attention in recent years. At this time, in late, 2015, yeah, around the time, it was still visible light. The Li-Fi was being developed, but our work, it was for not the wider range. We considered an application that can be used for very small proximity access. So that is smartphone authentication. Like one of my daughters had the fine motor issues, and she would be difficult to, and especially when she was younger, it would be difficult for her to type, letters on a small the phone. So our idea is that use a token that emits light, special encoded lights so that that can be used for authentication. And we call this work as an auth, optical authentication. So the high level idea is that there will be an emitter that emits light, like it coming from key fob. And smartphone has a lot of sensors, and one of them is ambient light sensor to be able to adjust the screen brightness so that it can save the energy. We use it for different purpose. The receiving the light token for authentication. So, and we also considered a number of security issues, and we have come up with the security scheme called inverse dual signature. So this can be used for special cases where in military or emergency respondents cases, people are wearing gloves, wearing masks. Facial recognition or typing would be difficult. Or also for people with a special needs, typing would be difficult. So how about use a special token that emits special signal? So this is the security mechanism um, that we came up with. And for this application, we have built the system with Arduino. In fact, our students, they have built multiple versions, prototypes of this work. And later we try to increase, this is not a high bandwidth application, but still try to improve the bandwidth data rate of this token and use the different brightness of the light.
Can I interrupt here for a minute?
Sure, yeah.
I'm so excited by this. You have no idea. Way back many, many years ago, there's a patent I have that I don't remember where, like what it happened to it, but we use this technique to communicate using video cameras. So using, certain, the LED or the light, whatever it is, the light source, right? Or
Uh-huh.
a color or something like this that could be either reflective or generating the light so that the cameras, as you come in, your badge is sending a signal to the camera and the camera becomes your verifier that it's you coming into that space.
Wow,
Yeah.
that's a very relevant. We should have cited your work.
It's okay. Nobody knows who I am anyway.
Yeah, it can be really bi-directional, challenge and response, right? Yeah.
Exactly. Exactly. And like these things, you wouldn't know by looking at the badge in some cases that it's doing that. So people could try to hack it just by thinking they could copy the badge and not really know what's going on if it's not in the visible light spectrum, you know.
Mm-hmm.
So these things are very helpful for security.
Exactly, exactly. I would love to know more about that. Maybe we can chat about it after this meeting.
Exciting, yes. I feel like such a nerd because every one of these things is so interesting to me. And I am really pleased that you tied it to your inspiration with your daughters because I think a lot of, yeah, we don't spend enough time with people because we like things better, right? So like I was talking to a friend who took me to the market and we went to another store and the next thing you know, some guy who saw us at the market came up and started talking with us and it was like, who is this guy? Like, because we're not outgoing, so to speak, right? But this guy had observed me in the store. And then like somehow in the other place, the other store, he remembered me and then started asking. And I think we miss that sometimes. When you have a child in your house, you don't miss that. You get to see what their experience is, right?
Right, right.
And
Yeah,
I
more,
think,
more.
if we get out more, yeah, we have to get out more and find out what the problems are that people have so we can solve them. Sometimes we just miss it. Yeah. So
Right.
thank you for bringing that aspect of these solutions to our attention. And sometimes it's missed on people. Like we try to put it into like humanitarian technology, whatever. No, this is doing technology well. This is meeting people's needs. This is understanding the needs. This is and it's not just one instantiation, it's like take that thing and then look at all the use cases that it satisfies, right?
Exactly. So, later I'm going to talk about the so-called, my insights. It's really use inspired, how people um, they will take it, how, what kind of needs are there, so, that's the message that I hope to bring at the end, right?
Thank you. I remember years ago, there was a story about the president going to the supermarket and he didn't know how to scan the grocery barcode or something. And, and but that's exactly the kind of problem that people who make decisions have, or people who design stuff who've gotten to the point where they're wealthy and sitting somewhere and they don't have to do that stuff for a living. So they're missing like so much of the important things about everyday life, you know?
Exactly. We need to understand others' needs, right? Different scenarios, different
Yep,
usage.
yep.
Exactly. Yeah. Thanks. So the last piece of the work, the project example, the relating to IoT is OptLock. So this again, we use the optical wireless communication. This time we use infrared rather than visible light, and we consider the great application for this communication channel would be, among multiple, we find the smart door lock. So, we can use infrared for smart door lock. I know these days we have the Wi-Fi, Bluetooth enabled the door locks. But we did this work earlier, 2015, 2016, before Amazon Ring was introduced. We were trying to commercialize it, but we couldn't beat the scale of Amazon. So, but at least we got this work out. So, um, the one of my daughters again, the I her school bus was not running on a day, and I had to pick her up, but I was running late, and she didn't have a phone then, and also she couldn't get into our house. We had a traditional door lock, and she was crying, and I finally arrived home. It wasn't too I wasn't too late, but still that moment was pretty the terrible for her, big, the traumatic experience for her, right? So I really decided, actually, after that event, we decided to change our door lock, at least to the number code door lock rather than traditional keys. So this work, we try to come up with the door lock that can be opened and controlled with smartphone. This work, we have done it before. Again, Amazon, the rings or other lots of smart door locks that were introduced around the time or after the time. So with this smart door lock, we can control the time of opening or who can come in. So this is actually gives amazing flexibility, um, and the um, existing Wi-Fi, Bluetooth can have a security issues. And infrared, it is a somewhat directional, not as highly directional as the visible light, but somewhat directional, and transmission range is somewhat limited, like 10 meters. And this is actually a perfect range. If it's a longer, it's more vulnerable for eavesdropping and attacks, right? So we find that this kind of application is perfect with the infrared. At the time, Samsung phone had an infrared emitter. So that's the we thought that this is a great the application we can put on our phone. And we actually have worked with our university. Still now our university has all the office doors, with the traditional locks. And how about if we do that with the smartphone? Then even if student graduate, keys doesn't get returned, still we can have a good security. So that was our um, argument, but it didn't happen yet. But anyway, this is our work. So the smartphone emits the infrared LED, and then the door lock, electronic door lock will have an IR sensor and get the signal. In this application, we thought about a number of security scenarios, the like phone stealing and the unauthorized access, eavesdropping, and so on. And we have a security mechanism around it. And also we have built a prototype with the Arduino um, and Raspberry Pi as well. We connected it with the electronic door lock, included an IR sensor, and they have a prototype with the smartphone and also server side as well, so that through the server, it can control different time, different user being able to open it. So one of the our research, the the novelty includes not only the security, but also this is the physical layer encoding scheme. The lowest, I'm a computer scientist, and we have come up with a physical layer encoding scheme with the infrared. We could change the duration of the infrared signal to control the bits, and we have done a number of experiments to have a best signal with a highest rate with less interference. We have done a number of the evaluations, and I'm not showing all, but definitely infrared is more energy efficient compared to any other RF the mechanisms. So those are examples of my IoT projects. Wi-Fi honk, Wi-Fi Amber, opt-aus, opt-lock, and we have addressed a number of issues. Okay, I hope that was somewhat interesting to you. So in terms of, say, insight, I talked about Wi-Fi, different uses of Wi-Fi, infrared, visible light. The I believe in diversity in many sense, and also communication method as well, rather than having one single method. The it's good for different purposes. The having diverse communication method. I didn't talk about here, but when I worked at NASA, the a way to have a reliable wireless communication for spacecraft, we come up with a scheme called the software-defined wireless communication, where we consider infrared, visible light, different the RF, and choose the one that is the most reliable at the time. Existing software-defined radio they only offers a few still limited transmission, limited frequency range, but consider wide variety of channel, and we can choose the reliable. Anyway, diversity is good to have. That's something I wanted to talk about. And then all these projects that I have explained, we started from the application or use, how others, where the needs are, and then came up with the design of the application, addressing technical issues like energy efficiency or security issues. Okay, so understanding the usage is very important. The necessity is a mother of invention. That's the message I wanted to convey. In different domain, similar approach may be called as a design thinking, or I would call it the empathetic thinking. Yeah. Okay, so that's something I thought maybe, no, it's somewhat insight. Another uh, thing that I observe, probably many others in this room as well, the looking at the longer time span of technology evolution, it goes in cycle, like even centralization versus decentralization. The student may see a snapshot of technology and see that this is the trend to follow, and the old paradigm is obsolete. That's not the case. I see the cycle, like mini mainframe, centralized computing versus personal computing, decentralized,
Uh,
cloud computing, SDN, centralized. Now we have IoT, edge, decentralized.
it's sorry to interrupt you.
Yeah, go ahead.
I wouldn't call cloud computing or even software-defined networks or edge under centralization. They are more distributed. The cloud computing, the difference between mainframe and cloud computing, in mainframe, it uses the client server model, while in cloud computing, it's more a distributed system model.
Um,
The
yeah, I don't disagree with that. Yeah, so yeah, it's a good point. When I say decentralized, is decentralized in a logical sense. Physically, decentralization, the use of lots of different servers, machines together. That's the essence of cloud computing. You're right, right. So, um, it can be viewed in a different ways. Um, but logically, I find that this is a centralized, a software-defined networking controller versus the software-defined networking switches. It's the compared to the traditional routing that are exchanging messages to learn about network topology, right? That is a really the totally distributed paradigm. But under SDN, there is a controller who has a global knowledge of the network, right? So that's
right, but you're still in distributed systems. What is happening there? You know, is essentially your control plane is being centralized. So in the past, when we did not have the network disaggregation, right? So now with the network disaggregation, we are able to separate the way we control the data flows in the network in a centralized manner. So our network policies can be centralized, which is a benefit
mhm,
because
mm,
if your policies cannot be centralized, achieving any kind of management can be a problem.
right. Yeah. Very
So right, so that I just wanted to make sure because while I understand why you're saying it this way, particularly with IoT and AI coming, but in reality, uh, when we are looking from particularly networks perspective, I think we need to be cognizant of the three planes of reference. While I understand where thanks for that clarification. I understand where you're going with this. Yeah, but the challenge is still going to be there though, especially when what you have called as the edge and fog, um, particularly when we are going to be enabling any kind of telemetric management. Today, telemetric management is more like a surveillance state, but uh, it's going to become a challenge because now we have to have centralization of control while decentralization of devices and distribution of both compute and systems.
Exactly. Yeah. Centralized control, distribution of physical systems. So what they wanted to point out is not, I didn't mean that, cloud computing is everything is a centralized. The really the concept, the centralization part, computing is done not at the user's device, but at a data center. There are, of course, a lot of servers used for say a single application, but they logically centralized. There are some centralization important centralization concept into that. So typically what it's meant is that for students, rather than looking at the technology as a snapshot and to try to ignore all the previous technologies, the having a broader spectrum of an understanding and use of existing older concept for new technology is really, it's worthwhile. That's what I
Yeah,
meant.
that's a very cool thought. It opens up a couple other possibilities. What happens when we have, say, for example, in your IoT, right, in some of your devices, you enable TinyML. So when you start doing machine learning there, you're basically your data plane merges with your management uh, or your control planes, right? So
Mhm.
basically, you remember back in the 80s, before the birth of SS7, we used to have where we could cheat on telephones, right? You can basically whistle your way to free calls. It's because your data plane and your control plane were on the same reference. SS7 basically separated those two. But now with what the cool idea you gave, it tells me that if I'm looking at data and doing some kind of tiny ML there, I'm merging both the control and data planes. Are we going back to the 80s or 70s where I can just whistle my way to free services?
So the older the concept, they're always cons and pros, right? The resource reservation, even or the we can even say the circuit switching, right? The versus packet switching. There are cons and pros, and they try to understand appreciate the older technology, the advantages and
Yeah, I bet you your time in South Korea in the telephone company there probably informed a lot of these ideas too, right? And and like I think back in the day, back in the early 90s,
Mhm.
when we had 142 switches in in the United States from coast to coast. And that it's hard to think of that as a centralized system, right? Because each one of those switches had like a whole bunch of stuff associated with it, and then it had a signaling network in addition to the stuff that was carrying the voices. It had a whole redundant set of networks that were handling the information about the calls, and so like I think most people don't have that level of experience or reference, and so having the history that you have,
very good. Amazing.
right? I
Because
mean,
have been experienced with the older previous systems.
yeah, I mean, even looking at 800 number databases, like how did that come about and where did they live and how do people look up the 800 number and find out what the real phone number is that that call was being routed to, for example. All of that stuff is based on what you're describing here. And I think a lot of people like to have a mental model at least to get started on their innovation, whatever it is. But if you actually have to engage somebody or something. I recently attended a talk where someone was talking about, oh, we do all this, and the person was talking about the AI and all this, whatever. And the next thing is like, but we still had to go and get a subject matter expert in order to do some of our stuff. And so then the question was asked, well, what kind of subject matter expert did you need? We needed somebody who knew about video coding. And I'm like, what the what? like what could you possibly do in the world that was meaningful without knowing that? And so like I think that we all have, like, we're really lucky in this room. We have such diverse experience, right? But I think what you're doing draws upon all of those things you've experienced that many people never get access to or exposure to in an academic setting, right? I mean, and so this is brilliant. I think it's inspiring, encouraging, and I'm just grateful people are, plugging into that and asking
Yeah,
these
appreciate
provocative questions.
it.
Yeah, yeah.
Thanks. Yeah. So,
Yeah.
um, Yeah, all of these technology, it didn't just appear ta-da one day, out of blue. It really evolved from the previous precursors and adopting some of the concepts, right? Yeah. Yeah, SDN, you can say we had an MPLS, the resource reservation earlier, or earlier, we had a circuit switching resource reservation. So that's pretty much it. I would love to hear more comments, questions, or discussions with the audience we have here. I just thought that so the title, technology, career in technology. It's a really broad title that I'm given. Um, I wasn't sure exactly how to direct the talk. So anyway, these are some of the questions that could be discussed in, say, professional development program when like women in the communications engineering do workshop. Yeah. So career decisions, industry versus academia. Um, well, there is no clear answer. You can be happy or not wherever you are. Uh, so I am happy where I am now. When I was in industry, I was really happy, to do impactful industrial practical research. So yeah, just I don't, nobody can say this is better than the other side. Um, but I thought that having lifelong learning, the attitude and the having curiosity all the time is always fun and helpful. Career planning, I didn't plan much. It just happened. If I knew how long it takes to finish PhD, probably I didn't even start it. If I knew what it takes to get a tenure or all those things, probably I didn't start it. I just, I think in some sense, not planning too much helped me. I recently read a book about unplanning, and if you plan too much with the detail, oftentimes you don't get the
Freeze
thing
if
done.
you
Let it
take the
happen.
slow track with additional, if you need additional.
It's a text to screen read, a screen to text reader, I think, that that
Oh,
we're hearing.
okay.
Yeah,
I see.
it's
So,
for it's the accessibility. It's cool.
okay. All right.
Yeah.
So the not planning too much can be helpful, at least sometimes. And then the general guiding principle that I find it useful is that when you are debating doing, do or not, typically just do it. The goal.
Exactly. Just do it. I love it.
No, if it's a good thing, particularly, just do it. Unless you
Yeah.
have a clear, reason not being able to do it, right? And then another thing is that just putting yourself in a new stimulating environment can, stir your curiosity more, and just that interesting things can happen. So I talked about my summer visiting faculty experiences at NASA, Air Force Research Lab, or Korea Telecom. All these different places, I find different technical issues, like NASA reliability is so important. Air Force Research Lab security is so important. I wasn't much of the security person before, but I got to expose to those problems, and it was really interesting to work on those security issues. So just I thought that this could be helpful
So
to
I think this might be a good time. This is your last slide. Is this your last slide?
yes, is it
Okay. Let's get rid of the slides and we can see everybody and have a nice chat here. I'm so excited that we had this chance to learn more about you and your inspirations, and